We'll get started here with our last talk. Um, Last but definitely not least, Marty Winchell from Veseris turned down a full pie to do this talk. So you know he's dedicated to this for us. And he's here to talk about application technology. So Marty, please take it away.
All right. I'm just changing everything. So is my screen being shared?
Yeah, looks great. And we can hear you
All
lovely.
right. Perfect. All right. Put that out, put that down. All I see is your face page, so I'm not sure what everyone else is looking, but as long as everyone can see it, that's fine. I tend to talk with my hands, so I put my screen on it, but chances are all you'll see is the side of my, or you might only see the side of my face while I'm reading, but if I decide to make some emotional gestures, it'll be in the video thing there. So yeah, thanks Paige for the invite to talk to AISC. Um, I hope that many people on this call were able to attend the annual conference. Probably one of the best attended conferences on this type of stuff that you guys will ever go to. So if you guys are on this thing and you haven't been to a conference, I would suggest you guys attend their conference. Also support them in any way. I was at meeting a customer yesterday. He had a Rat on Rats hat. So I'm seeing their swag everywhere that I go. So don't be afraid to support AISC in any way you guys can, because they're a great organization that's been around for a long time, and they're up for an Emerald Award this year. Is that right, Paige?
Yes, super exciting.
Yeah. Is there a way that we can vote for you, or it's a
I
committee
think
thing?
Yeah, I think it's a committee thing, unfortunately. We
We
could have
could have
rigged it
had
right
60
here, right
vote.
now.
Well, that's right. We could have had 60 votes for you, and probably 400 votes at the conference if we could have gotten people to do that.
Shoot.
So. All right, so I'm going to talk a little bit about application technology, lots about nozzles and how to make sure that the herbicides you guys are using, or pesticides in general that you guys are using, um, are are the most effective using the sprayers that you guys have. But I'll do what, when Tim started, he gave a little spiel about who he was. So I actually went back and quickly edited my PowerPoint. So I threw in a couple other slides as well. Let's see, is it working? Page down. Nope. There we are. That should work, right? You're seeing a different page. So that's who I am. I live in Rocky Mountain House. I've been in the range and pasture industry and vegetation management industry for 15 years. I've been involved in agriculture for over 25, and this is my third year with Veseris. This is my family, which is quickly growing. I have two boys who are both engaged and getting married this summer. So if you can't get a hold of me, it's because I'm either at a wedding or my daughter's grad. So be patient with me this summer. I threw this up there so that if you guys want, you can take down my contact information. Um, Phone number, email, probably the best ways to get a hold of me. That phone number is a cell phone, so you can text that number any questions you guys have, even if it's about Trico or anything along those lines. Give me a call, give me an email, and I'll try to respond as soon as possible. So I'm going to talk a little bit about herbicides in general to start, because what you guys use to spray and how you guys spray does depend on your herbicide. We'll talk a little about the plants, some objectives in dealing with some of the plants, different types of nozzles, and then of course we got to deal with using the right tool for the job. Not everything is, there's a lot of excitement about drone application in the industry right now, and it definitely is a great tool that will have a fit in the industry, but it will not replace all the other tools out there. And really, we all know integrated pest management. People talk about that a lot, and it's about having the most amount of tools in your toolbox so you can be effective, right? So I know this is, if you're on this call, you probably have your pesticide applicator license. So some of this is stuff that you guys already know, but I think it's important to sometimes take a step back and have a look at stuff. There are all sorts of ways that herbicides kill plants. So quickly, the difference between a contact and systemic herbicides, right? Contact herbicides only kill the parts of the plant that they touch, right? So if you are spraying with contact herbicides and you spray near a plant or beside a plant, you're not doing the job, or you happen to catch a leaf, you might not be able to effectively control that plant. So contact herbicides work quickly. They disturb cell membranes. They're good for killing annual weeds and controlling weeds in small areas. But I know a lot of people on this webinars are doing larger areas, and contact herbicides have their place, but they're not a one-size-fits-all. Systemic herbicides move within the plant to kill the entire plant, including the roots. Our previous presenter talked about, with the vinegar, it kills the top but doesn't kill the root, which often means multiple applications in the same year. I do believe that, the vinegar, I have a producer in Ontario who is using the Munger's vinegar because of the pesticide ban in Ontario. And they are having to do 5 applications of vinegar in 1 year. So you compare that to a systemic herbicide, which goes in, kills the entire plant. You can often only do one application, get away with one application a year. So the systemic herbicides move within the plant, best for perennial leaves and anything with an extensive root system. We all know that, something like thistle with a super extensive root system, removing the top does not kill the plant. The energy reserves in some of these root systems are extensive, right? Because they have to overwinter. So just removing the top killing the top does not effectively kill a weed with an extensive root system. So yes, modes of action, same thing. Contact herbicides are applied to plant foliage. That's the only way that it's going to be entered into the plant, where the systemic herbicides are absorbed through foliage, roots, shoots, can be taken up by the plant in many different ways. Contact herbicides are quick for visible results. Systemic herbicides are best for perennial weeds and those with extensive root systems. And we all know, even with the systemic herbicides, that the rate of kill is different. I always used to say that when you're using a glyphosate, you go out and you spray your glyphosate, come back a week later, and you almost think that it didn't work because nothing seems to be happening. So you go back to the shop, you mix up another batch of glyphosate, and in a couple of days you come back and everything's dead, right? It takes longer to apply. Systemic herbicides like 2,4-D, we can see results in a couple hours. Often you'll see curling of leaves before you leave the field. And some of the other systemic herbicides, take weeks before they work. And it depends on the plants as well. There's plants such as, the clovers and the dandelions. They take things up super quick, and sometimes you can spray a systemic herbicide in a field and see quick results on a clover and dandelion, but the oxeye daisy is still standing there as strong as it ever was, and it may take months before some of these slower plants are affected. So again, selective versus non-selective. A selective herbicide targets and kills only specific type of plants while leaving desirable plants unharmed. I don't know how many landscape people are out there, but lots of 2,4-D gets sprayed on lawns because it kills the broadleaves and leaves the grass. Products such as Trillion will remove all the broadleaves and leave your grass, so that it would be a selective herbicide because it is targeting a specific type of plant, the broadleaves. Whereas a non-selective herbicide kills all plants. It comes into contact. Something like a glyphosate kills everything. So essentially, selective herbicides provide targeted weed control, while non-selective herbicides clear everything in the treated area completely. Right, so the last grouping that I'm going to talk to you guys about is residual versus non-residual. I know this is all beginning, but that does determine how you pick your application method. Residual herbicides remain active in the soil for a prolonged period of time, providing long-term weed control, preventing new growth, while non-residual herbicides break down very quickly. And do not offer lasting weed control. Actually, interestingly enough, residual and non-residual is not always black and white. I had a question yesterday about 2,4-D. Was 2,4-D residual or non-residual? And we all view it as a non-residual herbicide, but anyone who is farming knows that you don't apply 2,4-D and then try and plant peas the following year, because there is some residual in the soil. We also know that the amount that you put down will affect how long it stays active in the soil. Herbicides have a half-life, so they don't, necessarily just disappear in 90 days. They break down over a period of time, and depending on how much you put down will determine how long it stays in the soil. So, yeah. Question number 1. We can go right to question number 1 page. And I guess I even do get to see it.
Oh, you do? Perfect. Does it show you how many participated too?
No, but it says that I can't participate.
Oh, so far
I didn't make the questions hard, right? Just enough to keep you guys, probably not even enough to keep you guys awake.
Well, I think so. You've got 77% participation, so
Oh, look at that.
I think
We'll see how many people participate on my Snoop Dogg question.
well, that was just a cliffhanger. Now everyone's gonna.
Oh,
I will close the poll here and share the results.
yeah. Oh, there you go. Perfect. Well done, people. Right? Contact kills only what it touches. Systemic moves through the plant to kill the entire plant. Perfect. Well done, everybody. So, all right. Page down. So one of the things we need to do is understand your plants, the objective of why you're spraying, and let's be honest, how you approach your application will depend on what your end result is. Lots of you, I recognize lots of the names that are attending today. And if you are looking at a bare ground program, you are definitely trying to kill everything that grows in that area. Whereas if you are landscape, you are looking at strictly getting rid of the broadleaves. And even more delicate, as it were, would be something like a canola crop. I don't know how many people are involved in agriculture on this call, but like if you were an industrial applicator and you're putting down 540 glyphosate, you're using liter, sometimes 2 liters, in a canola, Roundup Ready canola crop, you are definitely not wanting to damage any of your canola because that's the economic impact. So, you're using 0.75 or 0.5 of a liter in order to try and kill the weeds, but do absolutely no damage to your crop. So there's definitely difference in application. We should have people on this call. I know there's people on this call who do bare ground, people who do range and pasture, roadside and crop. So this is just some of the differences that you're going to be using. And even if you look at my units of measurement, it's always interesting that different applications use different units of measurement, right? You got bare ground people, and they're using high water volumes. They're talking in liters per hectare, so that's a double metric. Often rough terrain and slow moving, but have a very, very high water volume and total removal of vegetation. The range and pasture world, you're still wanting a high level of water, but you're talking gallons per acre, which is imperial. Often rough terrain, slow moving, and you're just removing undesirables. Roadside, often you are driving on the shoulder, so it should be smoother, moving much quicker. And then, of course, everyone who's ever seen a high clearance sprayer whip through a field at 25 kilometers an hour knows that those guys go whipping through there super fast, low water usage, smooth terrain, and they're trying very hard not to damage the crop. So even just looking at this quickly, you're not going to be using the same application method on these different applications. So some quick different types of nozzles that we use in the industry. Most of them are, the ones I'm going through are for a boom time application, because that tends to be the most diverse types of nozzles, whereas in the industrial world we tend to use boomless, and there's fewer options there, but we'll be going through that as well. So when you're selecting your nozzles, what are your application priorities? Whether you're roadside or crop, or I guess any of the other range and pasture or roadside, drift is a concern to everybody. When you're spraying roadside application, you will know that the most valuable tree on any property is the one that is closest to where you're going to be applying herbicide, right? The tree that grandpa planted back in 1909 that has been there for however long, and people are emotionally attached to, are the ones that are going to be hit by drift. So those things are things that you must take into consideration when doing an application. What pump are you using on your sprayer? If you can't get the correct PSI, then that's going to impact how fine of particles you guys are going to end up with. And then, of course, what are you spraying, and what's the modes of action? Selective, residual, contact, and then how fast you're going to be going. These Venturi nozzles in the picture there, you look at the two different applications, and traditionally, lots of the nozzles that we use, the higher pressure you use, the smaller particle size you end up with. But you look at the conventional, you're using a Venturi nozzle at 70 psi, and it's a very up down spray on this application. Whereas if you had your traditional T-jet nozzle and you're at 40 psi, those are a lot of fine particles that are prone to drift. So you want to make sure that you're using the right pressure based on these nozzles. And we'll go through a few few charts as well, just to make sure you guys are aware. Right, so drift, a big factor, lots of factors impacting drift. Your nozzle design, again, operating pressure, higher the pressure traditionally, the smaller the particle. Smaller the particle, the more likely it is to move and not go straight down. What you have in your solution, there are things you can add to your tank mixes that help particles go straight up and down versus being suspended in the air. And boom height. One of the things that we need to consider is boom height. Depending on where you live and the topography, there is a propensity to maybe have your boom height a little higher than it needs to be. Anyone who's ever sprayed with a large boom system and ran one of the sides of the boom into a side of a hill or hit a fence post with it knows that, if it had been a little higher, you might have prevented some mechanical damage. But if you have it up too high and there's any sort of wind, you're going to end up with some chemical damage off site. So we need to make sure that we're aware of what we're doing mechanically as well as environmental. What's the wind? What's the temperature? What's the humidity? We all know from our log books that you're writing all of these things down. And the rule of thumb when I was in the spraying industry and actually spraying is anything over 16 kilometers an hour, we shut down. Anything over 28 degrees Celsius, we shut down, right? So some of those things definitely come into play. You can't have gusting wind and expect herbicide to drop where you want it. And then, of course, you have fine particles and it's 30 degrees out. Those are never going to touch the ground. They're just going to evaporate and disappear into the atmosphere. So you're going to have poor, and it also, the plants shut down. Stomata close. You're putting herbicide on a plant, but it's not going to be absorbing it. So you need to make sure that when you're putting herbicide down, that the plant is receptive to it, it's actively growing, and you're not volatilizing the product. Right. So in a humidity also plays into that, right? At 100% humidity, it's raining. 2% humidity, everything is evaporating. So there's sweet spots for that as well. You want to make sure that things aren't evaporating too quickly, but you also want to make sure that you are operating within the rain fast realm on that product. And then, of course, we all know about inversions in your core manual. Spraying herbicide into a cloud mist on the ground in the early morning. You're just mixing it up with the cloud, and as things warm up, it can move off site very, very easily. So all of those things you need to take into consideration in your spraying program, and I'm sure all of you do, because you have to write it down. So here's an example of different units spraying the same crop. Obviously, one is going to be more prone to drift than the other. Pretty self-explanatory on that. And here's another example of a bad spray job. Right, droplet drift can cause environmental, economic, and health damage. So probably see some of this stuff in your guys' travel. I know if you guys end up in the Okanagan and you see some of the spray units that they have for orchards, they actually are shooting the product up, down, over, sideways, and if the environmental conditions are not great, you're going to have stuff like this all the time. So you got to make sure that you're operating within the environmental constraints of spraying. Here we are. Here's the boom height. I touched on this earlier. Higher booms are more susceptible to drift because there's more time for the wind to disperse the spray droplets. I have another chart coming up that sort of shows the fall rate of different droplet sizes, which is worth noting, because if your droplet size is too long, it takes quite a while for it to hit the ground. So in the case of something like this, not only boom height, but the very small droplet size also is likely to cause drift issues. Spray quality, right? This is, you can imagine this is an ant or a leaf or any other target that you guys are going after. And we talked about nozzles producing different range of droplet sizes. Often the higher the pressure, the smaller the droplet size. We also talked about systemic versus contact. So, we want to make sure that we're in a sweet spot when we're applying herbicide or pesticides in general, right? A large particle size, being the one in the top left, you may be getting enough herbicide down, but you're not getting good distribution on that pest, right? So you're hitting a leg, but you're not hitting the plant. And as you increase your or decrease your particle size, you may end up with it not hitting the animal either, because it gets suspended in the air too long as well. So there is a sweet spot in there where the particle or the droplet size is targeting the animal, but there's good enough distribution to get good coverage on that animal or plant or other target species. Right, so here's exactly what I was talking about. You look at this example right now, we have different particle sizes, and it shows you the different coverage on a sheet of paper that picks up moisture. So in the case of some of this extra coarse, you're seeing that there is product put down, but there's large areas where no herbicide has been applied. And then, of course, you get into the fine area as well, and you are looking at perhaps too small of particle size, and you may end up with drift and not getting the right application. So it needs to be somewhere in the middle there. So this is the line that's sort of arbitrarily drawn. You don't want particle sizes that are that big if you're trying to get good coverage. So you're not going to get good coverage. Question number 2. There we go.
Do you want to read out the question for everyone, just in case they can't
Oh,
see it? We can throw it in the chat, and everyone can participate.
all
Because I
right.
don't know where it would have gone.
Yeah. All right. Too high of booms allow for wind to carry herbicide off target, are related to Dr. Dre and Snoop Dogg death row records, allow for greater coverage on plant, and is easier on equipment when field is rough. So it is a single choice question. There is a best answer, even if there are 2 correct-ish answers. I feel like I'm the core test where there's kind of a trick in there too. So based on technology, what is the best answer? I'll give you a hint. It's not the last one.
John straight out of Claire's home. Love it.
Oh, awesome.
Must have been the one who put the death row records answer. So anyone just
Mm,
throw their last minute answers in there or in the chat. And I will close it right about now and share the results.
perfect. There we go. Well done, people. So, and that kind of works out. I got 4 questions and we're on question 2. So I think hopefully we're on pace to finish within the right time frame. Perfect. I don't know how much I want to talk about stuff like this. Nozzle flow. These things are all these. You can find these charts everywhere. Often, I don't know how many of you guys have been involved in boom systems, but often often you can get a nozzle body on there that has 3 different nozzles, and depending on the product and depending on the pressure, you end up with, say, a green and a blue and a brown, and that way um, you're able to look down the boom and say, okay, all the green ones are lined up perfect. I know I have them right, or I have all blue. Or you look down the line and you say, oh, I got 2 blues in my line of green, so I need to adjust them. So that's why they are color coded. But this gives you, how many psi you have and your gallons per acre at that different miles per hour. So obviously, the faster you go, if you were running a green one at 30 psi, traveling 3 miles an hour, you're going to get 6 or 8.6 gallons per acre. You bump it up to 8.5, you're going to get 3.0 miles or 3.0 gallons per acre. So, right, there's charts for all of these nozzles. So make sure that when you are putting nozzles in, they're not all created equal. They're not all the same. So you can't just pull one out, put another one in, and assume that it's going to do the same job. Right? Same idea, but this is more for spray. Up here you have fine, medium, coarse, very coarse, extra coarse. So same idea. At these different PSI, you can see as you increase the PSI, say on this yellow one here, as you increase the PSI, you can go from coarse to medium to fine. Right? So on these, you want to make sure you're not running the wrong PSI based on the nozzle that you guys are using. This is the if you guys are at all trivia buffs, as it were, this is one of the things that I like to. I don't know. I don't have it memorized, but this is definitely one of the things that is something that is very interesting. Right, the smaller the droplet, the lower it takes to fall and are drift prone. I've mentioned that already, but this this very much shows how quickly or how slowly some of that drift can disappear. Right, if you're spraying a very fine droplet out of a nozzle, you are it takes longer and longer to get there. So you look at the stop distance or whatever. If you have an initial velocity of 1 meter per second coming out of the nozzle, right, it'll stop sort of dropping after 21 centimeters, right? And the way that you can think about this is, let's say you have your spray bottle that you use either to when you're ironing, or you have a spray bottle that you used with your cat, if you turn your spray bottle and make it a very, very fine mist, you could spray it at your wife who's 2 meters away, and she won't be affected at all by the moisture coming out, because the smaller droplets don't have the ability to travel great, to travel, because they don't have the kinetic energy to move beyond a meter. So, and then if you turn that spray bottle and turn it into a jet, it's much, much easier to spray your kid when he's doing something that he shouldn't be doing, right? So hopefully that makes sense to everybody. So, you have a very fine mist, you have your high boom height, you have you're spraying along, and it's a very fine mist. It's not going to hit the ground. It's not going to get where it needs to go. So it's easy to talk about too coarse of spray, but I don't think there's enough talk about too fine of spray. So the finer the spray, the longer it takes to hit the ground. Right. So the retention of the pesticides. This is also this is sort of, we're switching gears a little bit here. When you're spraying, we all know that often we're spraying when things are actively growing. We're spraying to get the most effective use of herbicides or pesticides. So we need to know what we're using in order to make sure that we're getting the maximum value out of that product. So target size. This is a very, very simple demonstration of the target size and how a brandly newly planted canola field, when it's just sprouting, you look at the ability of that plant to receive herbicide, and it is, there's not enough plant there in order for you to spray and necessarily get an effective kill, depending again on the product, right? Sometimes you're planting or spraying the soil with the hopes that the root will uptake it. But if you are targeting a plant, and the plant is of significantly small size, then you're not going to get the herbicide on it that you need to, especially if it's a contact. Whereas a larger plant, you're going to get better coverage, because there's more leaf surface to absorb that product. So target orientation. One of the things that is probably nicer about killing a broadleaf plant than, say, a grass, is the fact that a broadleaf plant has a large surface area in which to receive the herbicide, right? You look at this broadleaf and it's sticking out flat, could be a leaf on a dandelion plant sort of thing, and it will sit there and you can spray it, and the droplets will land on the leaf, and they should stay there, and it should be absorbed by the plant. You end up with a vertical plant, some of the grasses and cereals, and they are very vertical. So if you are just shooting straight down, it is probable on a contact situation that you're going to be missing that plant altogether. So the orientation of that plant does impact the ability of that herbicide to work. Of course, we all know that there are defense mechanisms on these plants, and these plants are, the more you hate a plant, the more defense mechanisms it seems to have. We got two different defense mechanisms right now. And of course, some of these can be mitigated with surfactants or adjuvants. You got a defense mechanism on the left one, where it's a very waxy leaf. The waxy leaves the droplets will form and then roll off the plant. So in the case of something like that, adding a surfactant would help, because that creates less surface tension on water droplets, spreads the water droplet out a little bit more, and a greater surface area for for the droplet to stay attached to the plant. Also, hairy leaves, right? Some of the droplets can be held away from the plant by the hair on the plant, right? Prevents the plant from becoming in contact because it's been pushed away from the leaf by the plant. Again, adjuvants, surfactants can help with some of those issues as well. Okay. Talked a little bit about this already, so I don't know if I'm going to get into it, but your conventional nozzles, your T-jets, generally tend to be fine to medium. Produces a uniform spray between 15 and 60 psi. The flat fan tends to be more of a medium to coarse size droplets and has a narrower pressure range between 30 and 60. So it does produce a coarser spray. Now we're getting into some of the more, I won't say newer technology because this has been around for 100 years, but you get some of these spray things and they have a turbulence chamber that creates a wider angle of spray. And if you have a wider angle of spray, you are going to probably get better coverage on some of those more upright plants. And then, of course, they have a huge pressure spraying range between 50 and 90 and coarse to medium spray quality. Let's see if I can remember what question number 3 is.
See that one?
Oh, there you go. Yeah, I see it all. Plants can protect themselves from herbicide by being upright, being hairy, being waxy, and all of the above. Probably had 77 participation in the first one, and probably it's now down to 62.
72 right now.
Oh, way to go, guys.
I think I'll just wait for one more and then shut her down.
Well, the thing that I put in 4 questions, and I know in order to get credits, these things have got to go 50 minutes. So if we don't
That's
make the 50 minutes when we put up the last question, we'll just make sure that it's up there until the 50 minutes expires.
true. To be fair, we still have the ones in the Q&A, so you're not totally off the hook.
Oh, yeah, there you go. Yeah,
I will close the poll though and share those results.
there you go. Well done, folks. It's almost like you guys are listening. All right, do you close that or do I close that? Oh, you closed it. Perfect. All right, let's move on. Venturi nozzles. This is maybe something that's a little more new and interesting to you guys. These nozzles, you can draws the air into the spray as it's being sprayed down, and then you end up with droplets. It's sort of like bubbly water over flat water. And these form, that end up with liquid covered air bubbles. They shatter on impact, increasing coverage, increases the surface that these increases your droplet size will be an appropriate droplet size to hit the plant. But then once it hits the plant, it sort of spreads out because of the air bubbles in them. And you get greater surface area, like as if you were doing a finer mist, but it allows for the droplets to go down and hit the plant and get greater coverage and reduces the roll off. So, right. So more air induction. Okay. It's important that we talk about some of this boomless stuff because this is probably where I talked a lot about nozzles, and probably most of you are not using nozzles to the same extent that you're using boomless nozzles. But a boomless nozzle's main advantage includes maneuverability in tight spaces, versatility uneven terrain, reduced, you're not hitting a fence post with a boom if you're using a boomless. But right, and even for your industrial guys, you're loading up your UTV. Your UTV using two boom buster nozzles is giving you 30-meter coverage. If you were to had to have used a boom setup for that, that's a lot of tearing up and taking down. So, it's far more effective for lots of the application to have a boomless nozzle. You look at this boomless nozzle right now, right here, and it's got 7-meter swath. If you were to put a 7-meter boom nozzle on the back of your UTV, you're not just driving onto a trailer, strapping down and driving away. You're also folding up and stuff like that. So it is considered less effective in larger open fields, but that's why we have boom systems and high clearance sprayers. But again, the potentially coarser spray droplets, you do need a very large droplet size in order to be able to throw that product. If you're looking at half of a 7-meter swath, you got to throw it 3.5 meters. We go back to the spray bottle analogy. If it's a fine mist because you're running too high a PSI, you're not going to be throwing it out the 3.5, right? Also, in a case like a bloomless system, having a contact product is probably not going to serve you well because you're throwing large droplets out a long way and you're not going to get very good coverage on the plants that are out here. One of the things that I've run a number of boomless systems in my day. And we'd have producers who wanted to borrow sprayers to spray out their pastures using glyphosate. And yes, glyphosate is a systemic herbicide, but if the herbicide doesn't hit the plant, it's not going to kill the plant. So on a case of some of the larger pasture sprayers that we've used, you got a 30-foot swath. And really effectively, if you were to run something like glyphosate through that sprayer, you're really only going to have a 20-foot effective swath because you're throwing product farther out and it's not hitting the plant. So it's not. You want to be using products that are systemic and can be absorbed through the root system, can be on the ground and sucked up by the root system, can be absorbed through leaves and root shoots and stems. So great product, great for the industrial bare ground world, but not one size fits all. Here's an example of a boomless system. In order for them to get those droplets to spray out like that, and we go back to the droplet size, and if it comes out at 2 meters, it's only going to go, or 1 meter per second, it's only going to go 0.1 or 0.2 of a meter or 200 centimeters before it sort of hit that loss of kinetic energy and just sort of stays there. So you need the larger droplet size in order to create those swaths with the boomless system. Are the boomless systems fantastic in rough terrain? Absolutely. Are they fantastic for industrial applications where you're using residual products that are systemic? Absolutely. Great use. And they're cost effective. So one of the things that you guys need to make sure that you're aware of is that, I'll skip this slide. We're close to the end, right? So automatic flow regulators may reduce your operating pressure too far. So lots of the agricultural sprayers have flow regulators. So as you speed up and slow down, it adjusts how much is coming out the end. So you have even application. However, you get going too slow, and you're going to have a pressure that does not create the right particle size. So you have to make sure that you're choosing nozzles with if you have a flow regulator that at your lower lower speeds still give you proper water volumes and proper droplet size. Just another visual example for you guys so you guys can look at this and say, yeah, at these different pressures, I need to be, looking at the spray, making sure that it's appropriate. You get into this TJet XR at 75 psi, you can see all the fine droplets. But you get into the RD Ultra over here at 20 psi, and it's not enough pressure for it to be an effective spray pattern. It's a little bit self-explanatory, but I think it needs to be said, especially for people who have staff, that those filters need to be checked. We are seeing in the industry perhaps more and more granular herbicides being used. And with the more and more granular herbicides, my experience has been that you're also going to see more and more plugged filters. You always use the proper slurrying and proper application methods, but a filter can be 50% plugged or 70% plugged, and visually you cannot tell the difference in the spray pattern, even if you're doing it every day. So, and it may not affect every nozzle or everything the same way. So, make sure that some of the stuff is being cleaned, because this will impact your spray pattern. It'll impact your droplet size, and it will prevent you from doing a good job, and you'll be getting a call back to clean up some of your misses. So this is just the same thing I showed you earlier. So thought it might be a good thing for people to see twice, but you've already seen it. Right tool for the right job. I talked very, very quickly at the beginning that everyone's excited about drones, and so am I. The more herbicides we end up with drones, might be helpful, but they are not the right tool for every job. And you get into different situations, and you got to ask yourself, am I using the right tool for the job? I'm sure there's lots of people on this call who have never operated a high clearance sprayer, and probably never will, because you're not going to be needing to do 2,000 acres of canola, right? But if you were working in the oil and gas industry and you thought, I'll just buy a high clearance sprayer, I can just set it and drive in, spray, drive around the teardrop, drive out, fold up, keep on going, you're going to find that you're going to have lots of mechanical damage, because these things are not built for the rough terrain you guys see. And you put, you stick your arm out for 10 minutes and your arm gets sore. These things are cantilevered 60 feet out on either side. Every little bump makes that into the sprayer jump. Obviously not appropriate for oil and gas, but seems to work perfectly for agriculture. Very popular in the oil and gas is the middle one, using using handguns, easy to roll up and spray what needs to be sprayed. And then, of course, you get into systems where low density, super rough terrain, you're going to be looking at backpacks or pump ups of some sort. So there we are. Question number 4. And we don't even have to keep it up for 5 minutes to make sure we meet the time. Right? So when spraying in a random low density weed population in very rough terrain, the more appropriate sprayer to use would be. So not a lot of weeds. You're walking, or visually you can see half a dozen, but you're going to have to climb a berm and spray 3, and then you're going to have to go somewhere else and spray 4. What would be the appropriate tool to use for that job?
Pretty good, guys. We've got 75 participated. That went up
Oh,
real quick. I feel
everyone's still awake.
like We can close that for them. 77% share results.
Perfect. And absolutely, like if you look at the this UTV mount thing, if you know, you can run out 200 meters of hose. If you're happy dragging around that hose, although that hose is pretty light, you can use a UTV mounted thing. So that is not a wrong answer. It's just trying to think of 4 questions in an hour-long presentation. So 100%, you guys. Oh, oh, there we are. And I guess one of the things I will talk to you guys about as well is calibration. Everyone hates doing calibration, but anytime you do anything to your sprayer, you should calibrate it. I'll throw this up here if anyone wants to take a screenshot or anyone is not familiar with it. Super easy calibration calculator on the internet from Corteva. And in fact, if you just type in Corteva range and pasture sprayer calibration calculator, it'll pop right up. And you the enter the things that they ask you to, and it'll tell you if your sprayer is calibrated or. And you can solve for different things. You can say, I want to travel 5 miles an hour. How much or what does this need to be? And it'll figure it out for you. So if that can save you guys half an hour a year, whatever, use it. It's great. So make sure you calibrate. Make sure you're keeping a track on your spray pattern and check your equipment for defects. And keep an eye on your filters. If you guys are interested in that Trico or Trico, you can find it on Veseris.ca along with a lot of different spraying stuff. So there you go. Well, that should be good. Even
Incredible.
on time-ish, even if I ran through some of the last little bit.
Oh, that was perfect.
Or maybe
I've
not.
got 3 questions for you in the Q&A though. Um, John goes, wouldn't it be more cost and time efficient just to mechanical control if you were having to do 5 applications a year? I think I would rather pull or cut weeds twice than spray 5 times. Not a rhetorical question, curious if there is any data or anecdotal evidence for this.
Okay. I I don't know if it would be any more like because what they're doing is they in a I guess yes, we have somebody on here from Montana, but majority of people from on this thing are from Alberta, so I will just say Ontario. I think that's safe to say in an Alberta situation. Um, in Ontario, when they're doing the five applications a year, that it is on meridians. So maybe there's a safety aspect in there as well that you can just run your UTV down the meridian and spray vinegar as opposed to 5 guys out there on their hands and knees or whatever, right? So I mean, lots of these things are cut as well, but that is just the control method. Truthfully, it would be far more cost efficient and time efficient if they use trillion, right? If they could use herbicide. So and then it'd be once a year.
Beauty.
Oh,
Are there any
Patty.
recently new systemic herbicides on the market that are being used, and what is your experience or opinion with these products?
Oh, yes, yes, and good, right? Like I guess the other question is what's considered new as well. Um, because I'm in the chem world, I'm a little bit prone to knowing what's coming out there. Um, anyone who I don't know if there's any chem reps on the call. Hopefully not, but anytime a chem rep tells you that we got a product coming out next year, you can probably bet that it will be 2 to 5 years before it comes out. But there have been when I started in the industry, in the range and pasture world, dealing with tall buttercup, we were using MCPA, right? And then we were able to start using Garzel. or graze on. And then we were able to start using Restore and then Reclaim and then True Range. So that's just in the range and pasture world. So yeah, there's new products coming out every year. Right now, there seems to be a lot of push on products that will deal with kochia. So that, there's New Farm's got a product that should be out next year that looks like it's going to do some good things for kochia. Corteva's coming out with a product that's going to be sort of a kochia control program product. So yeah, there's lots of stuff coming out. And if you are interested in a specific weed in a specific area, there are opportunities to help these chemical companies with their research and do trials on them as well. So I mean, there's stuff happening all the time. And there are more tools in your toolbox. They don't work on everything, but they often work on what they're telling you that they are. And you look at something like kochia, which has a very, very quick resistance or develops resistance very quickly. We need to make sure that we're using some of these products effectively and rotating them very well.
Ah, awesome. There's one more question in there, but I feel like we hit our 12 o'clock. So if you want to type in the
Yep.
answer while I'm just reminding folks of last few things here. So only Marty's session will be recorded. We'll post that to our webpage as well as our YouTube. So you can check that out. I threw the links in the chat a little bit earlier. And again, for anyone interested in pesticide applicator credits, you will need to be logged on to that individual computer and accessing Zoom through the link that you registered with. After the webinar closes, a survey will be sent out, and that is where you will include your applicator number and birthday and all the relevant information for those credits. Um, Otherwise, thank you so much for our wonderful speakers, Tim and Marty. Last minute agreeing to present for us a few weeks back. It was great. We had speedy credit approvals too. So thank you all for attending last minute here. I think I sent that out on Tuesday. But yeah, um, again, just complete that survey at the end of the webinar, and it should also be in the follow-up email that comes from Zoom. But that's all we've got for today. So hopefully everyone has a chance to um, take in the Artemis landing today. I know I've been following along. Hopefully you guys are too, and we can all kind of pretend that we're together again for that at 6 o'clock. Of course.